Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 38, Gases Part 4. Here are our objectives for today's video. Pause here. So gas stoichiometry is just like any other kind of stoichiometry. It's just that we can use a unit factor that at STP, 1 mole is equal to 22.42 liters. And this works for any gas that is more or less ideal. And we actually haven't talked about any gases yet that aren't ideal. That'll be the last video of this chapter. This relationship only works at STP. If you are not at STP, you're going to need to use, you're going to either need to calculate the molar volume, which is just the volume of 1 mole of a gas, or you will just need to use PV equals nRT when you're finished and solve for moles for your calculation. Pause here. All right, so we'll start off with something pretty straightforward. This is more or less a unit conversion. 22.42 does not contribute to significant figures. 2.02 mole. Pause here. Okay, I'll work through this one. It is more or less just the regular old stoichiometry that we're pretty used to doing. The only difference here is because this is at STP, I can assume that 22.42 liters is the volume of 1 mole of CO2. Put this in my calculator. The 22.42 doesn't contribute to sig figs, neither does the 100.09. I got 69.9 liters. Pause here. So here's a mathematical relationship for density of a gas. Density here being measured in grams per liters and not grams per milliliters, just because the units are involved liters. You don't really necessarily even need to use this equation a lot of the time. A lot of times you can just calculate the mass and divide by the volume in liters. So don't feel like you have to use this equation. It will be useful for the next example, and you don't have to memorize it. So if you can do it, but you don't always need to use it. Pause here. All right, so first we're going to go ahead and calculate the molar mass here. And I got 28.1 grams per mole when I did that. Calculation isn't really the hard part here. You all are really good at plugging things into formulas. But then this question says, if this gas is diatomic, meaning it's like something too, what is its identity? So I go to my periodic table, I find something that has a molar mass of around 14, and it has to be a gas. You can't just pick something that's a solid. So this is N2. Okay, that's all for today. Thank you so much for watching and have a great night.